Yeah, nothing happened in this hour with the subject of biblatex, and although I've been aware of its existence for a long time, uh, I haven't done much in looking into it until the past few days. And I confess I was somewhat put off that biblatex is based on a new bibliographic engine underneath called biber, B-I-B-E-R. And together, the combined documentation is about 600 typeset pages. Now, clearly, bibliographies have a lot of complexity, but it doesn't seem to me it should take 600 pages to describe how to deal with them. And so I certainly have no plans to drop BibTeX and move to Biber, even though it's a newer implementation. But I think this problem is certainly not solved. One thing that Biber does is produce XML descriptions of BibTeX entries. Some publishers are very keen in that, and perhaps that will be the way of the future. But unfortunately, heavily marked up formats like that are not conducive to human preparation. They have to be done by software. And so that means there's going to be another layer of software in between. And what's appeared so far, there's a GUI that you can use to fill in entries in a BibTeX file, but it's so slow compared to doing things in a powerful editor like Emacs that I view it as worthless. And it's unfortunate that we have this problem that bibliographic data is hard to get right, even though publishers potentially have the exact data, they don't often produce the exact data in what they offer you in the form of BibTeX entries. And so, and the sources they upload to, like the DOI agency and Crossref and Web of Science and so on, those also often don't agree. In fact, there's a new paper in one of the Scientometrics journals where they looked at about a 5-year run of a particular journal and asked how many of these papers were recorded in Web of Science and in Scopus, another commercial database. And they found a significant discrepancy. And the whole paper then analyzes why. They're presumably both getting the same raw data from the publisher, but what ultimately got recorded differs quite substantially in some cases. So there's lots of work yet to be done in this area.
Do you know why or what the main motivation was for developing this biblatex stuff? Did people just not like BibTeX, or?
I think it was the issue that BibTeX style files, because of their programming language, are very, very difficult to modify. I mentioned in past tech office hours that one of the features of this BibTeX style language, it's a reverse Polish notation, like Forth and like PostScript. And that means that function arguments can be pushed onto the stack at arbitrary times and the function is invoked and everything is correct. This works just fine. It's when it doesn't work that you're at a loss to figure out what's wrong. And BibTeX itself does not have a method of printing the stack without destroying it. So it's extremely frustrating that you're stepping through a BibTeX file with debug statements in the BibTeX style file. And when you really need to see what was on the stack to find out why this function isn't working as expected, you've just wiped out the complete history of how you got there.
Yeah, I mean, I certainly
it could be fixed, but it requires changing BibTeX.
Yeah, I mean, I certainly wouldn't want to work with it directly, but that's the beauty of the Merlin and the custom bib stuff. It's very user orientated. What happens behind the scenes, I don't know, I don't care. And, you know, anybody can produce a style file with an arbitrary description in just a few minutes. So I'm surprised that people went to the trouble of going to make something new which needs 600 pages to document.
But the problem with producing new bibliography styles is we're making the problem worse. Instead of simplifying and reducing it to two basic styles, a numeric and an author date format, we're adding one more style to the morass.
Yeah, that's true. But you know, we're not calling the shots. It's the publishers, it's the journals who want their unique stuff. And there's really, I don't know, I don't think any way to get around that.
Yeah, and as As an example of what can happen is our University of Utah thesis office decided that bibliography should follow the style of major journals in each field of study. And then they went out on their own and decided what those major journals are, which isn't necessarily what people in the field believe. Yeah. And now students are being forced to find bibliography styles that try to come close to what those journals are using. And of course, the journals themselves aren't static either, because every few years they undergo redesigns. IEEE Spectrum has a new design as of this month. It looks radically different than what they had before. ACM went through this with the communications a couple of decades ago and radically changed the view of that journal.
I mentioned last week that a recent paper went through 8 proofs, and today I got something of an explanation, namely that between submission and production, a completely different company took over the production of the paper. There were 2 involved. One was more for editing, one was more for production, and they changed. And apparently in this process, they want to change the reference style as well, but nobody told me. And that would have been okay if they had, converted the stuff automatically to the new style, but they apparently did it by hand. But I think as you mentioned, the ultimate goal would be you just provide a list of DOIs and they can format it however they want.
Yeah. As an
that
experiment,
works only if there's a DOI for everything. Yeah.
As an experiment, I've created a set of styles based on Oren's original 4, the plain, unsort, breve, and alpha, that wrap all of the output fields in the BBL file in macros. And then other code can take that BBL file and reconstruct a complete BibTeX entry for it. And this is just an example of how you don't want to lose the input markup in the output. We've talked about this in tech and in PDF files as well. It really is useful to have that markup preserved all the way through the production from the first input until the final output. And currently, basically all systems lose it. And that loss is severe.